The world is on the cusp of a technological revolution driven by machine learning, a fascinating subfield of artificial intelligence. Machine learning empowers computers to learn from data, identify patterns, and make decisions with minimal human intervention. This transformative technology is rapidly changing the way we live, work, and interact with the world around us. From personalized recommendations on streaming platforms to self-driving cars navigating complex traffic, machine learning is leaving its mark on every aspect of our lives. The seeds of machine learning were sown in the mid-20th century, alongside the birth of modern computers. During this era, the world witnessed the advent of machines that could perform calculations at unprecedented speeds, revolutionizing various fields such as mathematics, engineering, and science. Early pioneers envisioned machines capable of simulating human intelligence. These visionaries were not just dreaming of faster calculators, but of machines that could think, reason, and learn. Alan Turing, a renowned mathematician, proposed the Turing Test in 1950, a concept that would become a cornerstone in the field of artificial intelligence. The Turing Test was designed as a benchmark for determining a machine's ability to exhibit intelligent behavior equivalent to, or indistinguishable from, that of a human. This idea sparked a wave of research and development in the quest to create intelligent machines. Arthur Samuel, a pioneer in computer gaming and artificial intelligence, coined the term machine learning in 1959 while working at IBM. His work was groundbreaking and laid the groundwork for future advancements in the field. He developed a checkers-playing program that demonstrated the ability of computers to learn from experience, a concept that was revolutionary at the time. This program was not just a simple game. It was a proof of concept that machines could improve their performance based on past experiences. This pioneering work laid the foundation for this revolutionary field. The early efforts of these visionaries have paved the way for the sophisticated machine learning algorithms we use today, impacting everything from healthcare to finance and even our daily lives. At its core, machine learning enables computers to learn from data without explicit programming. Instead of being explicitly programmed with rules to follow, machine learning algorithms are trained on large data sets. This training process allows them to identify patterns, make predictions, and improve their performance over time. Imagine teaching a child to ride a bicycle. You wouldn't provide them with a complex physics lecture. Instead, you'd let them practice, learn from their mistakes, and gradually improve their balance and coordination. Machine learning encompasses a diverse range of algorithms and techniques, each with strengths and weaknesses. These algorithms can be broadly categorized into three main types: supervised learning, unsupervised learning, and reinforcement learning. Understanding the differences between these learning styles is crucial for comprehending the full spectrum of machine learning applications. Section 5. Supervised learning, learning from examples. Supervised learning is akin to learning with a teacher. Just as a student learns from a teacher's guidance, supervised learning algorithms learn from labeled data. This method is fundamental in the field of machine learning and artificial intelligence. In this approach, algorithms are trained on labeled data sets, where each input is paired with its corresponding output. These labeled data sets act as the teacher, providing the algorithm with the correct answers during the training process. This helps the algorithm understand the relationship between inputs and outputs. The algorithm learns to map inputs to outputs by finding patterns and relationships in the data. Over time, it becomes proficient at making predictions or decisions based on new unseen data. This process is iterative, involving continuous refinement and adjustment to improve accuracy. For instance, imagine training a model to classify emails as spam or not spam. This is a common application of supervised learning in the real world. By analyzing a large number of emails, the algorithm can learn to identify characteristics that are typical of spam emails. You would provide the algorithm with a data set of emails labeled as spam or not spam. This data set serves as the training material, allowing the algorithm to learn from examples. The more diverse and comprehensive the data set, the better the algorithm can generalize to new emails. The algorithm would learn from this labeled data to identify features that distinguish spam emails from legitimate ones. Features might include specific words, phrases, or patterns in the email headers. Once trained, the algorithm can then be used to filter incoming emails, effectively distinguishing between spam and non-spam messages with a high degree of accuracy. Section 6. Unsupervised learning, finding hidden patterns. Unsupervised learning, on the other hand, involves learning without a teacher or labeled data. Algorithms in this category are tasked with discovering hidden patterns, structures, or relationships in unlabeled data. Consider a scenario where you have a data set of customer purchase history. An unsupervised learning algorithm could be used to group customers with similar purchasing behaviors into distinct segments, even without prior knowledge of these segments. Section 7. Reinforcement learning, mastering through trial and error. Reinforcement learning draws inspiration from how humans and animals learn through trial and error. In this paradigm, an agent interacts with an environment and learns to perform actions that maximize a reward signal. The agent receives positive rewards for actions that lead to desired outcomes and penalties for actions that result in undesirable outcomes. Over time, the agent learns to make optimal decisions by maximizing its rewards. Section 8. Machine learning in action reshaping industries. The impact of machine learning is being felt across a wide range of industries, transforming traditional practices and creating new possibilities. In healthcare, machine learning is being used to develop personalized treatment plans, diagnose diseases with higher accuracy, and accelerate drug discovery. Financial institutions leverage machine learning for fraud detection, risk assessment, and algorithmic trading. The transportation sector is witnessing the rise of self-driving cars powered by machine learning algorithms that can perceive their surroundings, make decisions, and navigate complex environments. Section 9. The road ahead, a future shaped by machine learning. As machine learning continues to evolve at an unprecedented pace, its impact on our lives is only going to grow more profound. This technology is not just a fleeting trend. It is a transformative force that is reshaping industries, economies, and societies, from healthcare to finance, from education to entertainment. Machine learning is becoming an integral part of our daily existence, from personalized education tailored to individual learning styles, where students can learn at their own pace and receive instant feedback, to advanced research tools that help scientists make groundbreaking discoveries. The applications of machine learning in education are vast and varied. To smart cities that optimize resource allocation and enhance the quality of life for citizens, the possibilities are limitless. Imagine cities where traffic flows smoothly, energy is used efficiently, and public services are tailored to the needs of the community. These are not just dreams of the future, they are becoming realities thanks to machine learning. However, the rise of machine learning also presents ethical and societal challenges that need to be carefully addressed. Issues such as data privacy, algorithmic bias, and the potential for job displacement are significant concerns that require thoughtful solutions. It is crucial to engage in open and inclusive discussions about these challenges to ensure that the benefits of machine learning are shared equitably. As we venture further into the age of intelligent machines, we must also consider the long-term implications of these technologies. How will they shape our future workforce? What new skills will be required? How can we ensure that everyone has the opportunity to thrive in this new era? It is imperative to ensure that these technologies are developed and deployed responsibly, with a focus on transparency, accountability, and fairness. Policymakers, technologists, and society at large must work together to create frameworks that guide the ethical development and use of machine learning for the benefit of all humankind. By fostering a collaborative and inclusive approach, we can harness the power of machine learning to create a future that is not only technologically advanced, but also just and equitable for everyone.